We have observed that big data is anything which has got three essential characteristics. Is anything which has got three essential characteristics: volume, and then variety, and then velocity. And we also observed volume and variety are going to throw me the problem related to the storage, and velocity is related to processing. So how we are going to address our storage need in terms of volume and variety? How you are going to address your processing need in terms of volume and variety again? When you have huge volume of data, how quickly you can process? When you have wide varieties of data, how quickly you can process? If you are not able to process the data quickly, you are not able to give the results to your end users, and there is no point in. By the time you shared the results, the disaster might have already happened. You have your storage been well addressed using your HDFS, and your processing is well addressed using your MapReduce. And both these put together, we technically call it as Hadoop, or simply Hadoop core. So we must start our discussion with Hadoop only. Specifically, as part of this one, you start your discussion with HDFS. Only when we are clear about HDFS, we will not be able to move to MapReduce, because you must be able to first store the data. Then only we can think about processing it. So how we store data, huge volume of data, all these things we need to learn. So before we talk anything about HDFS, it is my regular practice that I make people to understand things very clearly, especially the basics. Then their foundation is going to be very strong. On that you can build anything you like. I can simply say HDFS is a distributed file system specific to Hadoop, and ask you to go through some documentation and leave it to you how you understand. But I never do that, because this being the foundation to our entire learning process, I want you to be very clear. If you fail to understand HDFS thoroughly, you will not be able to understand most of the things in the coming days. That is where let us start our discussion with FS, that is called file system. Try to understand what is file system thoroughly. Then try to understand what is distributed file system. Once you understand this one, then we can add Hadoop to that and try to understand what is Hadoop distributed file system. Then it makes more sense. Before we understand anything about HDFS, it is good that we understand about file system. We understand about file system. Can you please share with me, friends, what you mean by file system in your own terms? This is just to get the inputs from your end, your understanding about the concepts. File system. Please feel free to share whenever possible, so that it makes more easier to have wonderful interactions.
It's a It's a method to actually store data structures and files.
Oh, that's good. That's good. Really convincing. Convincing. Anything better than that? Anything better than that, friends? Nothing wrong. I mean, I don't say. This is the best, way that you keep up your simple things. In computing, I follow wiki, where you get very good and simple information explained in a simple terminology. In computing, a file system or a file system, a single word, is used to control how data is stored and retrieved. File system is used to control how data is stored and retrieved. Is used to control how data is stored, not just storing, at times when it is required, how you can retrieve. How data is stored and retrieved. Without a file system, information placed in a storage medium would be one large body of data with no way to tell where one piece of information stops and the next begins. So they are telling very clearly, if file system is not there, again, storage is just one piece of data to us. We never know where something is getting stopped and the next one is beginning. By separating the data into pieces and giving each piece a name, the information is easily isolated and identified. That's what we are doing with your directories, subdirectories, and all these things. I hope you are following with me what I am trying to share with you here. So you can have number of definitions for file system if you go across. I don't say that you must remember this definition only, but I want you to understand this. Once you understand this, you can define in the way you want. Is used to control how data is stored and retrieved. Without a file system, information placed in a storage medium would be one large body of data with no way to tell where one piece of information stops and the next begins. So what is a file system now? File system is an interface with which we manage the data stored on the storage media, so that we can have control, full control, where some data begins and ends, where the next one begins and ends. We'll have full control. So not just storing, our goal should not be just storing the data. At times when it is required, we must be able to access that quickly. Then only it makes sense to store the data. I hope you are following with me what I'm trying to share with you here. So you look at this one closely, you really understand. I think you are following with me why I'm initiating this discussion, because big data is anything which has got three essential characteristics: volume, variety, and velocity. Volume and variety are linked up with your storage. Velocity is linked up with your processing. How and where you store huge volume and wide varieties of data is a challenge. How you can quickly process huge volume and wide varieties of data is the next challenge. And these two challenges are addressed decently by a software framework called Hadoop. As part of Hadoop, we have two main, you call them as components or categories, whatever. One is HDFS and the other one is MapReduce. HDFS takes care of storing your huge volume and wide varieties of data, and your MapReduce is going to quickly process or instantaneously process your huge volume and wide varieties of data to make the results shared almost like on the fly. I don't say on the fly, nearer to on the fly. Data comes in, gets processed, and the result starts going out. That is possible with your MapReduce because of its massive parallel processing technique. We talk about that one a bit later. And I also want to show you this is the best way to make your technical skills upgraded, friends. Hadoop.apache.org is the site from where you get the actual and the original information regarding your Hadoop core. I mean, for every component that we learn in the coming days, Pig, Hive, Scoop, every component has got their own existence as part of Apache Software Foundation in the form of hadoop.apache.org. Then you have your hive.apache.org, pig.apache.org. Same like you have different so you have different top level domains, subdomains for each project, because all these are the top level projects at Apache. Under Apache, you have all these as top level projects, comes as subdomains. Hadoop.apache.org. You see what they're saying? Apache Hadoop. The moment you hear the term called Apache Hadoop, you must get into mind HDFS and MapReduce put together Hadoop. Apache Hadoop project software or project develops open source software for reliable, scalable, distributed computing. Reliable, scalable, distributed computing. This software library is a framework that allows for the distributed processing. Observe this one, friends. For the distributed processing of large data sets across clusters of computers using simple programming models. Very interesting, you see this. Allows for the distributed processing of large data sets which are spread across multiple machines in the clusters using simple programming models. That's what the beauty part of your Apache Hadoop. This project includes Hadoop Common, Hadoop Distributed File System, Hadoop MapReduce, and Hadoop Yarn. We are going to see even Yarn as part of our program, but the first and the foremost that we try to learn is your Hadoop Distributed File System. Is a file system that provides high throughput access to the application data. High throughput access to application data. You appreciate. All these are the projects at your Apache. The top level projects at your big data level. Ambari, Avro, Cassandra, Chukwa, HBase, Hive, Mahout, Pig, Spark, Tej, Zookeeper. And there are few projects which are in the incubator stage, not the top level projects at Apache, but still part of your big data space. So we try to see even those things. Some of them been specified here, others not been specified. This is not the complete stack. But to understand all these things, you need to start your journey with your storage first. That is the reason why we are talking about HDFS. As part of HDFS, we want to start discussing something about file system, understand it thoroughly, and then go to distributed file system, understand thoroughly, then come to your HDFS. Then we can start working with the commands related to your HDFS. That's what the path that I laid to make you to understand these aspects. So for that sake, I want to introduce the concept of file system to you in a simplest way. That is, let us talk about one of the simplest file system. We are taking the use case. The file system we are taking is FAT. I need not tell you what this is. This is actually your file file allocation table model. File allocation table, that is called FAT. File allocation table. This is one type of file system. If you see the number of file systems that are in existence, oh my God, you'll be really thrilled to see the number of file systems you have till date, varieties of file systems you have. List of file systems, if you see, you come to know disk file systems like this. You see how many are there in the disk, out of which there is one thing called file allocation table on DOS and Microsoft Windows, where we have FAT12, 16, 32, FAT12, FAT16, FAT32. And you also see file systems with built-in fault tolerance. File systems are optimized for flash memory, solid state media, record-oriented file systems, shared disk file systems, distributed file systems. So don't be under the impression that HDFS is the only distributed file system. No, a number of file systems, out of which your distributed file system with fault tolerance, that is what your distributed parallel file systems. You see, your HDFS is actually a part of your, which you're going to see here. Hadoop distributed file system is a parallel fault tolerant distributed file system. It's parallel, fault tolerant, and moreover distributed file system. So you can get the information about the file systems in all detail here. So we are trying to understand along the way to your HDFS, we are laying the foundation with your very basic file system called FAT, and make you to understand what is FAT, how data is organized in your basic file system called FAT. Then we can easily think about scale up to your HDFS. Look at this one. Okay, so you look at this one, you understand. In file allocation table model, you want to store your file called file A. And before that, I need to tell one more thing, friends. Your entire disk or your storage media is divided into uniform blocks. Say, this is what your storage media. Okay. This entire thing is divided into uniform blocks, usually of 4 KB, 8 KB, something like that. All these, this is entire thing is called disk. Whatever you are seeing here, all these are called your blocks. I hope you are following with me, friends. More specifically, these are called uniform blocks, usually of the size 4 KB, 8 KB, 16 KB. Please follow with me, friends. I am saying here specifically 4 KB, 8 KB, 16 KB. Why I am stressing on this one? For the reason, when you go to your HDFS along the way, you see the same story repeated there, uniform blocks, but of the size 128 MB, 256 MB, 1024 MB. That's what the fundamental difference you find between your traditional file systems and your Hadoop distributed file system. That is why I'm stressing on this one. Usually the size of these blocks 4 KB, 8 KB, 16 KB. Your entire storage media is divided into uniform blocks. Can you tell me what is this process called, friends? What is this process called? I think, when you get your new media, you attach to your computer. You think it's possible you straight away use that?
It's probably the formatting.
Fantastic, fantastic. So that is what we call it as formatting, right? So without formatting, you'll not be able to use that media, right? So during your formatting, what we are doing is we are trying to divide this into uniform blocks of whatever, based on the file system that you are using to format that, you'll be able to get the blocks, right? That is what I'm trying to show you here in this slide. Your storage media is already divided into uniform blocks ranging from 0 to n, the block numbering from 0 to n. Now, I want to store a file by name file A, which requires 3 blocks. Then in my file allocation table, I'll be saying like this: file A, the start block is 2 and the length is 3. I hope you are following with the diagram what I'm trying to share here. File A starts with 2, 3 and 4, where your data related to file A is being stored here. Anytime in future, I want to retrieve the data of file A, I look into this FAT, that is called file allocation table. I understand it has 3 blocks. The start is the second block, that is numbering with 0, 0, 1, 2. I go there, fetch the next 2 blocks, including that 3 blocks, and that's what the data related to your file A. I hope you are following with me, friends, what I'm trying to share here. And file B starts with the block 9 to the length of 5, being shown in the gray color. Again, file C starts with the block 18 to the length of 8, 18 till 25. And intentionally I'm showing you here, file E starts at 30. I think you notice that here. File D starts, file E starts at 26. 26, 27, 28. So it is not necessary the files needs to be in that order, and files needs to be, because there are blocks in between left over which you notice here. Now tell me, what is the challenge with this one, friends? What is the challenge with this file allocation table model with contiguous allocation or contiguous file allocation? Please feel free to share, friends, your opinions, because I want to make the sessions to be more interactive so that
maybe we cannot use the storage space uh, properly. Maybe the optimum usage of space maybe we cannot achieve maybe.
absolutely, absolutely, because you see between file A and file B, you see 5, 6, 7, 8, 4 blocks are not being used, and that is the reason why we do, what is this called? I don't know whether you experienced that any time before, friends. There's something called disk fragmentation. You notice that any time? Sometimes what happens, your computer will have storage space, but you will not be able to use much because of your data being spread across your storage media, and you're not having sufficient data to get stored. That is why we do compaction. We do compaction. With the compaction, what happens? All your storage will be pushed to one corner so that all the unused blocks will be left, and those can be used comfortably for any of your storage needs. But what is the problem here? What is the problem here?
Sir, here if file A wants to get still some more blocks, let's say it requires still 2 more blocks, then it is highly impossible in this allocation pattern to allocate extra space
Not
in the
highly,
contiguous memory allocation.
yeah, we cannot say highly impossible. We cannot say highly impossible, but what we can say is if file A requires 2 more blocks, maybe File A has been already stored. You're opening that for the next time. You're trying to add something more to that file A, which demands 2 more blocks. Then what needs to be done is those 3 existing blocks need to be copied to the new location where I am able to get 5 continuous blocks. Those 3 needs to be copied to the new location, delete the old ones, make the new ones to be the current one, and then only you'll be able to. All this process, I think you are following with me what I'm trying to share with you here. So what happens is all the 3 blocks, the continuous blocks what we have now, I need to do it in such a way, I need to allocate 5 blocks somewhere where they're available, copy all this data over here and remove all these 3, make this as your current. All this process needs to happen. So when there are frequent modifications to your existing content, then this is going to become expensive to me. It's going to become expensive to me. I don't say it's not possible, but it becomes expensive. I hope you are following with me what I'm sharing. Is that right? I don't know who shared with me.
Yes, sir.
Is this Aravind?
Yes, sir.
Yeah, I think
Yes, sir, it's me.
now I think you're able to understand. All right?
Yeah, I understood, sir.
So here if you see, now I think you notice that here, you see. What is this now? In order to address that only we have something called, it is the same fact. See why I'm taking this as use case, it is simple and easy to understand, friends. And the same fundamentals are the base even for your Hadoop distributed file system. They're no different. In the chain allocation model, under the same fact, in the chain allocation process, file B, start block is 1, same story, length is 5, but you see at the end of my block 1, I have the details about what is the address of the next block, next block, next block, next block. I hope you are following with me what I'm sharing here. So what is the advantage with this compared to the earlier one? The blocks need not be continuous. The blocks need not be continuous. I hope you got the sense. The blocks need not be continuous. They can be anywhere. But still, I want to have 2 more blocks to be added comfortably. This is something like your linked list, which you might have studied at your basic education. Same like your linked list. All of you agree with me, friends?
Yes.
Yes.
That's wonderful. That's wonderful. So you see, in this chain allocation again, over a period of time, the same old story gets repeated. To make it more faster in terms of accessing, I do compaction. So that it is chain allocation only, no doubt, but after consolidation. That is what we periodically apply on your storage disk compaction. Disk compaction, what we do. And you see here now, index allocation with block portions. Index, I think you noticed here, friends, what is the difficulty? You want to reach the 4th block. You like it or you don't like it, you must pass through all the first 4 blocks. Then only you can come to the 5th block. Because this is something like your linked list. If I want to reach the 4th block, or the 5th block or 10th block, I must pass through all. I think you remember, you recollect your traditional tape recorders with tapes, your cassettes. You want to, which doesn't have any forward or rewind mechanism, you want to listen to the 4th song, you must listen the first 3 songs, then only you can go to the 4th song. Of course, at the later stage, you have fast forward mechanism, you have rewind mechanism. You want to listen to the same song again, you can rewind and play. That all as part of the evolutionary process. Same even here. You see the traditional growth of your file system. let me come from the beginning. You have your continuous allocation model in the fact which we are seeing here, and we require disk compaction for that. Then it happens so that all your empty storage is been pushed to, all your storage is been pushed to one corner. The leftover can be used by you for your comfort. And because of the limitation we have there, we move to the chain allocation with compaction. Now, this also is a bottleneck in terms of my access. My access will not be fast if I need to read the data one after the other. That's the reason why the same fact again, but this is index allocation with block portions. What we'll be having is, we'll be having something called index block. That index block will have the complete details about all the blocks that belongs to this file called file B. That is called index block. Index block. That index block will have the complete details about the blocks that belongs to this file. You see, file B index block is 24. 24 carrying the complete details about where all the data belong to file B is being stored and their order. Able to understand my point, friends? Able to understand my point,
Yes.
friends?
Yes, yes.
Yes.
Now tell me, what is the advantage with this model? I'm able to store like how I used to store in my beginning, but I will be able to get the random access to my data. If I want to go to the 10th block, I need not travel all the 9 blocks to reach the 10th block. I can directly go to the 10th block. That is where my random access facility is being enabled here. Random access facility is being enabled here. I hope you follow and you are with me on this, friends. So what is a file system now? File system is an interface between the media, the storage media and the user to enable the flexibility of storing and retrieving the data in a convenient fashion. Once you understand the concept, you give it in the way you know it. We need not remember the standard definitions been given by someone. We can comfortably work with all the we can look at all the standard definitions, try to understand and derive on our own so that we can retain it for a longer time. So how our discussion has started now? Our goal is to understand about HDFS, and this is what one good policy that I follow all the times. When you fail to understand something on its own, divide into small slices, try to understand each slice, you will be able to understand the bigger one. As a part of that process, we are understanding the file system now. We have understood the file system. Now tell me, when file system is already in place and you are able to store your data, retrieve that as per your comfort, why you require something beyond your file system? We have understood what is file system and why we require something beyond. I give you a classical example, friends, here. It is you. I allocate 4 people under you to manage. And you simply say, yes, definitely possible. I manage them. Down the line, 2 months, I added 4 more. Down the line, another 10 days, I added 10 more, 20 more, 50 more, 100 more. You still able to manage?
No, it gets difficult managing more.
Yeah. To your laptop, you have added 1 TB storage. Of course, one thing is there that your motherboard will not support to add hard drives of your choice. That's a different story. I want to bring it to your notice very clearly that your operating system or your hardware has got the limitation in attaching the storage media. That is what I want to bring it to your notice. To your laptop, you can add 1 TB storage. Yes, it recognizes the entire. Your operating system able to see the entire 1 TB storage. Of course, which is divided into uniform blocks. That's a different story. But your operating system able to see the entire 1 TB storage. Keeping that thing in the mind, you add one more TB to your operating system. It says yes, possible for me to see even that. You keep adding like this, you think your operating system able to see any number of TBs?
No, there is upper limit to how much it can see.
Now I ask you the question, why that upper limit?
It should be able to access it, right? I mean, a 32-bit machine can only go to so much of
Oh,
storage.
fantastic. I really appreciate. So that's all the hardware architecture limitations and all. That's where I give you one classical example. With your naked eye, you may be able to see 50 meters properly. Maybe you want to see something beyond, you take the help of binoculars. You want to see something beyond, you take telescope. You want something beyond, maybe you require more scientific or bigger telescopes to look into galaxy. Same like your operating system able to see only the storage of certain level. You may have the ability to add more storage to it, but it is not able to recognize. Now, if my need, grows, if my what need? My storage need grows beyond the manageable limit of operating system, at that stage what I do? When my storage goes beyond the manageable limit of the operating system, definitely I need a way, because you see the organizations getting the data into them day by day, minute by minute, second by second. It is exponentially growing. When data is coming at that exponential level, definitely a day comes or time comes where it grows beyond the manageable limit of the operating system. Even an individual like you or me, you calculate yourself a typical use case, friends. That is 1st Jan 2015 till 31st December 2015. You see, roughly, I'm not saying you precisely calculate, you calculate how much amount of data you might have gathered as an individual, downloading the documents, downloading the audio files, video files from the internet, creating documents on your own, making documents on your own, varieties. Maybe it comes around about 500 GB. Imagine, I think 2016 Jan 1st till date, you might have already surpassed that. Long back, you might have surpassed that. Which means as storage is becoming more and more cheaper to us, that is one reason, and your needs also getting increased. An individual like you or me, when our needs are getting increased so drastically, I need not tell you about the organizations of different sizes, how their needs are going to grow. There is definitely an exponential growth. When the storage need grows beyond the manageable limit of the operating system, I cannot say I'll not be able to store. I need to find out a way how that needs to be stored, how that can be stored.
You just spread it to many.
Absolutely. Like how when you are not able to, you are packing your baggage. When you are packing your baggage, you fail to pack your entire thing in one suitcase. You are going to divide that into two suitcases, right? Three suitcases, four suitcases. You keep increasing linearly. Same like I'm talking about your luggage. Here I'm talking about data. No more difference. There is no difference between your luggage and the data here. When you're not able to store your entire luggage in one suitcase for your travel, then you're going to keep your luggage, you divide your luggage into two parts and put it in two suitcases. Same like if this is what my data which I want to store it, if it is not possible to be stored on one box, I divide this into two parts. This I store it on one machine and this I store it on another machine. This is what the data I have and this is what the storage, I mean the machine I have. This is my first part and this is my second part. But you see, like how earlier I used to store my entire data on machine. This is a machine where I used to store my data. This is my data. Even now, your data is being split into two parts and being stored on two different machines. But to an end user, how this storage is looking like, this storage and this storage should look like the same to this end user. That kind of illusion I should give to the end user. End user should not feel my data is being divided into two parts and being stored on two different machines. Maybe, but it should look like single. The illusion which is going to give me that feel of both the storage as a single storage is called my distributed file system. No doubt it is a file system. When I'm using this term called file system, it is single. File system is always singular. But my file system is no more a centralized file system. It is a distributed file system. I mean, my file system is spread across machines. Earlier, my file system is confined only to one machine. But now, my file system is spread across multiple machines. I hope you are following with me what I'm sharing with you. But ultimately, you see, in terms of the end user, like how you used to work with his file system before, he must be in a position to work with this new file system. I mean, like how I have a single root when I'm here, same like let I have two machines or three machines, even this third part, I put it here. Let I have two machines or 300 machines. All these put together, again, I should have only one root. Under that root, I can have the file system. Under that, I can have file system again. Under that, I can have file system. But ultimately, it drill downs to a single root. Like how I have a root here. Same like even in this case, I need to have a root, which means it looks and works like your earlier file system only, but physically the storage is not happening on one machine. It is being distributed across multiple machines. The interface which gives me the feel of working with this entire storage, the interface which helps me in working with this entire storage of 20 machines in the background as a single user interface is what we call it to be distributed file system. Are you able to understand this one, friends? Please feel free to share with me. Srinivas, we are not able to understand. I don't mind giving you other 10 examples to make you to understand.
Sweet, could you please tell me what is this root? Can you come again?
Root is something like, I'm talking in the context of Linux file system. I think, your entire Linux box will have a single root. Of course, when you come to your Windows kind of operating system, you have C drive, D drive, E drive, F drive, something like that, right? Same like when you go to your Linux box, you have a single root. You agree with me? Let me show you that. No issue. Let me show you that. I'll connect to my say here. Okay, one second. Yeah, connected. So let me see that. Root admin 123. You see here under root, you see that one here. This is what the root I have. Under root, you see this one, all present under root. All this is the directory structure at my root level. Okay, everything starts from root, that is /, right? Like how this is one machine. Please watch this one carefully, friends. This is one machine, right? That is my IP address 15. I hope you're following with me what I'm sharing here. This has got single root. This is an independent machine which has got single root. Even I go to my Hadoop cluster where I have my Hadoop cluster which has got 6 nodes. My Hadoop cluster, my live Hadoop cluster has got 6 nodes. All these 6 nodes having my storage spread across. I'm going to show you physically all those things, then you'll be able to understand. I have my master, I have my slave 1, slave 2, slave 3, slave 4, and I have C manager. Altogether 6 nodes I have. Now the same putty, I log in into my, I say here, this is my 40, that is a master, root, and you see, here, Hadoop fs-ls root. My file system is spread across, observe here friends, my file system is spread across 6 machines. But still it has got root again. Under root I have temp, under temp you have something else, under root I have user, under user you may have something. Like how my independent machine, which is this one, you look at this, even my distributed file system is giving me the same. This is my, you see, at the root level I have all these things. At my root level I have these things. Now tell me, if I don't show this back one, I show only this one, these two I show, will you be able to understand that I have 6 machines in the background for this Hadoop cluster? Now looking at this, can you tell me I have 6 machines in the background?
No.
That's what I am saying here. That's what I am trying to share with you here. You look at this one closely. Now the end user, the end user here never comes to know whether I have 30 machines in the background or 300 machines, because this interface is going to give me the illusion that the entire background is one storage, not multiple storages. But physically, if you go and see at the very grassroots level, yes, they are independent storages, but working collectively for a common goal. I hope you got the understanding what I mean by distributed file system. It is also a file system, but the file system distributed onto multiple physical machines, but working collectively. You take out, see, it is not possible that I take out only this file system out. Not possible. All put together, one file system only. All put together, one file system only. We cannot have something like that. It is not possible. Only one part I can take out. It doesn't have any meaning. All put together only the file system, because file system is always a singular. But the thing here is your file system is distributed onto multiple machines in the background. That is what you need to understand here, friends. Machine, are you able to
Yes.
understand? Are you following with me what I'm trying to share with you here?
Yes, I'm following with you. Yeah, I attended late, like 9:45, but I'm still following you.
No issue, no issue. I will make sure we'll streamline the things. I appreciate. Annapurna, wonderful to see you today. You have anything? Probably I'll call
No,
you.
I got it. Let me verify myself if I got it right. So you're saying that it's a multiple machine, and multiple machine is distributed to the multiple file, but they're working at the same as one purpose or one things, and come up to the one single file. Like,
Absolutely. Absolutely. That is what we are trying to see here. You look at this one closely, you'll be able to understand the same thing here.
but the connection it does by automatically, or you have to do it like because
No.
you distribute it to the file to different computers. I understand that, to process quickly. Okay, I got that. But there is any way probably it has to become like everything has to be connected to each other, that working together. Otherwise, separate would be how it has to be connected.
Yes,
That's
the
what I
same
mean.
thing. The same what we are seeing here as part, like how your storage is divided into uniform blocks. Even at the distributed storage level, your storage is divided into uniform blocks. Your file is going to be split into blocks, and those blocks are spread across multiple machines. Tomorrow when I need that file, I know this file is present on these three nodes or these three machines, and in these blocks, all those blocks put together my data to the file.
Okay.
That is why we are not depending on direct. We are not directly going to the machine and interacting. How we are interacting? We are interacting through an operating system called distributed file system. So
Okay.
we see this entire thing through, like how we are seeing through a file system here. Same like we see this entire structure. We see this entire structure through, I'm going to show you now. Say physically you have, this is one machine, this is one more machine, this is one more machine, and this is your file. And this file is divided into 4 parts, 2 being stored here in the form of blocks, and this is being stored here, and this is being stored here.
Right here.
Okay. And when you are seeing, with the help of distributed file system, I see all these blocks belongs to one file only. I will not see them as blocks. Like how I am able to see here very comfortably, I am able to see here, right? Hadoop fs-ls, and I say at root what is there, that it is showing me. Like how my ls-l at the root. This is my centralized. What I am showing you here is one machine, centralized file system. What I am showing you here is a decentralized file system called as distributed file system, which is spread across 6 machines in the background, but you never come to know that there are 6 machines in the background or 60 machines, because your interface is providing me the illusion that it is one single storage, not multiple storage.
Yeah, I got it.
That is what the beauty of your DFS. You got the point, Marcy?
Yeah, I got the point.
Wonderful, wonderful.
So, so only the master runs the Hadoop file system. The slaves do not, right?
Yeah, sorry.
Slaves just run the.
Come on again.
Only your master has the distributed file system software. The slaves don't have that.
No.
Is that how it
The
is?
slaves also will have. But slaves
Okay.
also will have. But thing is, master knows the entire information where your file is stored, into how many blocks it is divided, where those blocks are present. Only that information is known to the master. But
Who is master?
every machine will have the file system present, the distributed file system present.
What do you mean by master?
No, don't worry. We are going to HDFS directly, so don't worry. When we have 100 machines connected in the network, there should be a gateway to enter into that network, right? You call that as a master.
Oh, okay.
Okay, you call that as a master. Yes.
So why do you say Hadoop FS on the master? What happens if you say Hadoop FS on the slave machines?
Oh, classical thing. I go to now slave 4. That's a wonderful question. That's what I mean. I'm very much interested to hear these kind of things. Even sometimes I fail to answer. I don't hesitate. No, I don't know about it. Give me time. I'll come back. I don't mind. But these are the things that definitely essential. I move to slave 4. You notice that? I moved to slave 4.
Yes.
You notice that? Root at slave 4.
Yes.
Right? Now here I am saying Hadoop FS-ls. Did you get anything different?
I just see two structures here. So when you do a Hadoop, if you do a just ls root, you will see more, right?
No, that is your centralized file system, which is connected to a different machine altogether. That is 15, which is my developer machine. That is my developer machine here. I think you see here. Dev Apache, this has got 15 IP, and all the others are having different IP. This is something like this. Even on this one, you see closely, Hadoop FS-ls and say this one, I get this structure. But I say ls and /, I get this structure. Which means every node has got an operating system called CentOS, but all nodes put together has got one more operating system called Hadoop distributed file system. We'll talk about it, don't worry. Don't get confused yourself. This is only to make you to understand why we require distributed file system. Don't worry anything about Hadoop now. We talk very in detail about Hadoop at the later stage, but this is only to make you to understand why we require a distributed file system when we have a centralized file system already in place. That if you are able to understand, we can comfortably go to Hadoop distributed file system and talk about it separately and detailed, because I cannot end Hadoop distributed file system with 15-20 minutes discussion. No, it is a full-length discussion on Hadoop distributed file system. We talk in detail about it. But I want you to understand clearly, when we have a centralized file system in place, why we require a distributed file system. That if you are able to understand, yes, we are done. And in order to show you that thing, as I don't have other distributed file systems set up on my network, I am compelled to show you Hadoop distributed file system as an example. But honestly, we are in the process of doing like this. We understood file system. Now we are trying to understand distributed file system. Then we actually go to Hadoop distributed file system. As I don't have a distributed file system set up on my environment, I'm directly showing you HDFS. But otherwise, under DFS, we have number of file systems available, which I have shown you in the list before. In that, Hadoop distributed file system is a special category called parallel fault tolerant distributed file system. This is what these are. We talk in detail. Let us not be hurry in understanding that. But I want you to be clear why we are moving from. Let me show you this slide once again. Why we are moving from here to here? Because to improve the storage efficiency. My blocks are spread in between, which are not usable to me. I need 20 blocks continuously. I have 20 blocks, but I don't have 20 blocks continuously here. That is why I am doing compaction. You agree with me?
Yes.
So I went here, but after going here, what I felt, if file A needs to be modified frequently, then a frequent structural modification is encountered here. I need to constantly move file A from one to the other, and again the same old story repeats. My blocks gets distorted. That is why what I have done is I went to chained allocation. But in chained allocation, what trouble I have? Then accessing these blocks which are spread in different sectors, different tracks, the movement is going to be difficult. That is why I am doing what I am doing. I'm doing my compaction. Again in chained allocation only, I'm doing compaction. So that reading is going to be faster. It is no doubt chained allocation, but it is going to be after compaction. But what is the problem with chained allocation? It is linear accessible. If I want to go to the third block, I must pass through the first two blocks. Then only I can go to the third block. In order to overcome that, I came to this model. What is this? Index allocation with block portions, so that I can access all my blocks randomly. I need not go through the blocks or access the data of these blocks in a linear fashion. Like how I am trying to go in the evolutionary process, that one to the next one. Now, if my need grows beyond the storage limit on the storage media attached to the operating system, what I do? You got my point? If my storage need grows beyond the manageable limit of your operating system, then what I do? That is where we started discussing something called, I slice my data into manageable limits of each operating system and push this data onto those machines. But collectively, all these machines should work together for the same cause called single storage. It cannot be treated as independent storage. It must be treated as single storage only, because storage is never multiple. Anything you take, distributed or Hadoop distributed or anything, I use the term called storage. I never use the term called multiple nodes. Maybe to understand the concept certain times, I use a term called multiple nodes in the background and all, but I use the term called storage, which means one single entity. Maybe as part of the storage, I have 10,000 machines or 10,000 nodes or 10,000 hosts. That's a different thing. But all put together, to me, it is single storage only. The illusion of a single storage from multiple machines is given by your distributed file system. See, when I see these things directly, I treat them as independent. But when I see these things through this one, like this, if I see, it looks like single storage. That is what the beauty part of the interface called distributed file system interface. This interface is going to provide me the feeling of single storage that is done on multiple independent machines. Are you getting my point, friends? Are you able to understand this one, friends?
Yes.
So
I have a quick question in between.
yeah, please.
So when you put it to different machine, like that's not the HDFS, like the other machine, so those machine has a specific capacity like 1 terabyte or something limit, has a limitation. It's not like unlimited.
Yes.
So in so you have to know how much those machine has storage, and you have to put that based on your knowledge. You have to know how much is available and how much you're gonna just put it in there.
Exactly.
But so you have to do it your own math. Like if you have a 1 terabyte and you have the like 10 machine, which is each has 10 gigabytes. So you have to do it your own math and distribute it. You have to distribute it to equally, or is unequally is okay, even though they are able to do the process.
Yes. So usually what is being done is these distributed file systems are developed in such a way they are going to distribute the data uniformly so that there will not be heavy load on one machine and less load on the other machine. Even over a period of time, what happens, you keep adding the files, deleting the files, then they become unbalanced. You'll be having a command or a software present with the distributed file system to balance the storage. No problem for that.
Oh, so it is done by the software. You don't have to do it manually.
Exactly. We did not do that manually. We schedule that program. It will take care of distributing the data uniformly on all the nodes so that one node encounters heavy interactions, other nodes are idle, will not happen. That is the reason why I've shown you this example, like how we are doing the disk compaction here. Same like we are going to do the load balancing.
Okay, that sounds good.
So you'll be having something called load balancer. When you run that load balancer, it makes sure that on all the machines you will have uniform load, not more load on few machines and less load on some machines.
Okay. Thanks.
Yeah, wonderful machine. Yeah, that's great. So I advise you friends to go through this one, whatever we discussed in the today's session. Please go through this one, whatever we discussed about file system, distributed file system. Please do some homework to understand these things in detail. Most of the time this has been neglected. People think I learn few commands, I know how to work with the distributed file system, I am done. Yes, definitely you are done. But the level of understanding you gain by looking at these terms and these concepts precisely will give you the imagination at such a level, oh, you have everything in the mind. Your entire HDFS is in your mind. Then you know how to lay the architecture and how your storage needs to be maintained. You have everything in the mind. So you need to come to that level. That's what my feel. So please, friends, try to go through this one. Whatever I'm trying to discuss with you in the today's session, please make sure that you go through this one so that we'll be able to continue the next session with HDFS very comfortably. Also, please go through whatever I'm mentioning here. Hadoop.apache.org, Hadoop.apache.org. You please go to that and see that Hadoop.apache.org gives some basic understanding of what is distributed file system and what is Hadoop distributed file system. And I mean, only a few statements. I'm not asking you to go through this and come to the session. When you go through this one, you get acquainted to certain technical terms, which will be easy for you to follow the session. That is why I let you know in advance that if you can go through these things, it will be easy for you to actually, it will be easy for you to actually follow the sessions very comfortably. So I advise you to do two things. One, please go through